And just like that, we're already at day 5 of Unit 1. So on day 4, we looked at measuring segments. Today, we're going to look at measuring and constructing angles. So first, let's talk a little bit about constructing the angles. So an angle is formed by 2 rays or sides with a common endpoint called the vertex. You can name an angle by several different ways. You can name it by its vertex. So let's say we had an angle like this. We could say that's angle R. By a point on each ray. So let's say we had this other angle that has A, B, C. So pick a point on each ray in the vertex. So we would call this angle A, B, C. Or we could say angle C, B, A. Notice though, when we do that, which one is always in the middle? B. So where you turn the corner has to always be in the middle. The other two, it could go either way, but where you turn the corner must be in the middle. Or we could name the angle by a number. So over here, like if this had a 4 in the corner, you could say that's angle 4. So those are all different ways to name angles. The set of all points between the sides of the angle, so everything in the middle, kind of going off of what we drew already. I'll do a pink. Like if the set of all points in the middle here is the interior. So I'm going to highlight interior, just color coding my notes. So everything inside is the interior. Another way to think of this is if you take an interior design, what are you designing? Or if you want to be an interior designer, what do you want to design? The inside of a house. Interior, inside. The exterior is the set of all points outside the angle. So just like at a building, if you're on the exterior of the building, you're outside. If you exit the building, you go outside the building. So exterior is outside. Okay, first example, they want us to write all the different ways that we can name the angles in this diagram. So let's first start with the big angle. Angle SRU. So angle SRU. Now remember what I said up here. As long as the letter stays in the middle, we can flip these and it still be the same angle. So angle URS is talking about the same thing. Now let's look at that top angle. There's 3 different ways you can name that angle. You can call it angle T. Of course, we could flip that. Angle TRS. But then in this little turn right here, as we're naming the angle, what number was in there that I just kind of covered up? Angle 1. That's all describing that one angle. Now let's look at the bottom angle. We could say angle TRU, or again, if you wanted to, you could flip that. Angle URT. And then what number is down there in the bottom one? Oh, where'd my page go? There it is. Angle 2. So one diagram, but 8 different angles that we could name. Okay, so that's constructing an angle. Now let's talk about the measure of an angle. So the measure of an angle is usually given in degrees.
Sorry, I couldn't quite hear you. Could you please read?
Sorry about that. Since there are 360 degrees in a circle, 1 degree is 1/360th of a circle. Now, like I said, they're usually measured in degrees. If you go on to pre-cal, they could also be measured in radians. We're not going to worry about that in here, but if you go to pre-cal, you'll learn about radians. We'll also have to talk about it again in the future just because sometimes our calculator likes to go into that mode, but we don't want it to. But anyways, getting off topic. So back on track. Let's look at types of angles. Now, chances are you probably remember what these are called. So if we have this small angle here, less than 90, we call that an acute angle. So it's going to be greater than 0 degrees, but less than 90 degrees. Now, if it's exactly 90, that's a right angle. Right angles are exactly 90 degrees. And then we have, now we're getting bigger than 90. We're going to have an obtuse angle. So it's going to be greater than 90 degrees, but less than 180. We have a special name for one that's 180 degrees. Yeah, it's called a line. So this one is also called a line. But the angle itself is called a straight angle. If it's a line, it's a straight angle. And it measures exactly 180 degrees. So now let's measure these angles using this protractor and then classify it. So we've got to measure it and then classify. So the first one is angle AOD. So it's going to be this one, A. I'm going to go to O, and then I need to go up to wherever D is. Okay, so I guess we can classify it first by looking at it. What kind of angle does it look like? And we can use our pictures up above. Yeah, it looks like an obtuse angle. Obtuse. So now it comes time to measure. Well, the A is down here at the bottom. So the measuring is going to take place at wherever D crosses. So kind of somewhere in here. Now, since it's since it's obtuse, we've got to be greater than 90. Well, the outside, that would be 15. Is that greater than 90? No. So we've got to use the bigger numbers. So it looks like we're exactly in the middle between 160 and 170, or 165. So we're going to say this angle is 165 degrees. Okay, now on to angle COD. So we're changing up the angle. It's going to be this one. And we still go up to D. Now we already talked about where it kind of crosses at D. So it's 15 out here, 165 in here. Let's focus on C. Inside, we're looking at, oh, wait, not 85. We're between 70 and 80, kind of in the middle. So 75. Outside, what are we going to be? Where does it cross? Between 100 and 110, so let's say 105. Now, here's the deal. Since we didn't start at the bottom, we're going to have to do a little subtraction. But you can't cross numbers. And what I mean by cross numbers is if we use the inside numbers, so if we say, oh, we're going to use 165, then you've got to use the inside number over here to subtract from it. If you use the outside, if you say, oh, I'm going to use 15, then you have to use 105 to go with it. So these two go together, and these two go together. You can't cross over between them. It's not going to work. So I'm going to use the outside and say 105 minus 15. Now here's the deal. No matter which one you use, inside or outside, you'll get the same answer. You just got to pick a side. So 105 minus 15 gives me 90. So this angle is exactly 90 degrees. What does that make it? A right angle. Not to be confused with a wrong angle. Okay. Next one, angle BOA. Let's erase all of this so we get a clean picture here. Okay, angle BOA. That's going to be this line and this line. What kind of angle does that look like? An acute angle. an acute angle. Okay, so we're starting on the bottom, which is good. That AO is on the bottom, that's good. So we can just go up here and try to figure out which one I need to read here. So inside it looks like we're at 40. Outside we're at 140. Now since we're an acute angle, which one of those do I need to use? I want to be less than 90. Good, the inside. So this angle is 40 degrees. Okay, so let's go to the back of the notes now. Now we're going to have to do a little bit of math. This is called the angle addition postulate. So if S is in the interior of angle PQR, then this was kind of like that segment addition postulate we did yesterday. So saying S is in the middle of the whole big angle here. So I just kind of gave y'all a hint. This is whole. What can we say? Well, we can say that angle RQS plus angle SQP is equal to angle PQR. So we have that part plus part equals a whole deal all over again. Now it's really important that when you draw your angles, you pay attention to what it's telling you. So if we look at this example 3, it says D is in the interior of angle ABC. So we need to draw a picture just like I had y'all do yesterday. D is in the middle. And then our main angle is A, B, C. And now let's label what they give us. It says ABD. So ABD, that's talking about this angle right here, is 37 degrees. The measure of angle ABC, so the whole thing is 84 degrees. What is DBC? So what's this? Let's call it X. That's what we're trying to find. So how can I set this up? Well, we have that angle addition postulate that we just talked about. Part plus part equals whole. So 37 plus X equals 84. Now we got to solve for X. Subtract 37. We get X equals, let's see, what is that? It's going to be 7. X is 47. So that means the measure of angle DBC is 47 degrees. There we go. Okay, keeping it moving. We have congruent angles now. So just like with congruent segments, you have congruent angles. And they're marked by these little, they're called arc marks. So that shows that those two angles are congruent. So since angle ABC equals angle DEF, we can say they're congruent to each other. Angle ABC is congruent to angle DEF. Now, just like how I mentioned on segments, if you want to show another pair was congruent, you could draw something maybe like this. I don't know, maybe I want to do it like that. And then if I put one mark, that means they're the same as the ones drawn, but they're not. So I'm going to put 2 marks, which means the ones with 2 marks are the same, and the ones with 1 mark are the same. Okay, now we have another definition, angle bisector. We remember back to yesterday, we said bisector does what? Cuts in half. So an angle bisector is a ray that divides an angle into 2 congruent angles. Or another way you could say this is 2 equal angles. So just like with a segment bisector, for an angle bisector, the parts are equal to each other, but you also still have part plus part equals whole. So let's use that for this next example. And remember, we need to draw pictures if they don't give it to us. So it says BD bisects angle ABC. So I'm going to draw my big angle, angle A, B, C, and then a ray that starts at B and goes through D is perfectly in the middle here. So the top is congruent or equal to the bottom. Okay, let's see what else they tell us. They say ABD. So the top angle is 6x plus 3. And DBC, the bottom angle, is 8x minus 7. Find x. Well, if they're congruent, because we have a bisector here, what does that mean about each individual part? They're equal. So let's set them equal to each other to solve for x. So I'm going to say 8x minus 7 equals 6x plus 3. Subtract your 6x. 8x minus 6x is 2x. Minus 7 equals 3. Add your 7. I'm out of room, so I'm going to continue up here. It's going to give us 2x equals 10. Divide by 2, and you get x equals 5. Now check, what did they ask you to find? They ask you to find x, so we're done. Okay, last example of the notes. Then we can say we've survived notes. It says L is in the interior of JKM. So I'm going to draw that. It doesn't say it bisects. It just says it's somewhere in the middle. So L is on the interior of J, K, M. Now let's label what they give us. They give us that JKM. So the whole thing is equal to 10x minus 7. JKL is 5x. And MKL, so MKL, that's the bottom angle, is 4x plus 6. Find x. Okay, well, what do we know? We have each part and we have the whole. So we know, or we remember, that part plus part equals whole. So let's set that up. 5x plus 4x plus 6 equals 10x minus 7. Now we can combine like terms. So 9x plus 6 equals 10x minus 7. Let's move our 9x over so we can keep x positive. It's going to be 6 equals x minus 7. Add 7. I'm out of room, so I'm going to continue up here. It's going to give us 13 equals x. Or, of course, we don't leave our answer like that, so let's make sure to flip it and say x equals 13. Is that all it asks us to find? Yes. Find x. So we're done. Okay, so there's the Unit 1, Day 5 notes. Here in a little bit, we'll do the guided practice.